Guys, so in this video, we're going to talk about bisectors, distance, and midpoint. And so this last unit, or the last lesson that we had, we talked about segment addition postulate and what all that meant. And we kind of started talking about midpoints, where we talked about the midpoint being the center of a line and cutting it in half. So in this section, we're going to start talking about what it means to be a segment bisector and all of the things that come with it. So the first thing we see is segment bisector, and we define that to be a segment line or ray that intersects a segment at its midpoint. So line L bisects MS at point D. So they're giving us this picture here, or the description of this picture. So we have line L right here, and then segment MS with point D in the middle. So what is the first conclusion we can make from that statement? And that is that point D is the midpoint of segment MS. The second thing we can conclude is that segment MD is congruent to segment DS, or that the length of MD is equal to the length of DS. So now let's look at this picture and this statement, and let's answer some questions about it. So line HL and line KT are intersecting at the midpoint of segment HL. So since we know that they're intersecting at the midpoint of HL, we know that M is the midpoint of HL, meaning HM is congruent to ML. That is all that we know from that statement. We don't know that M is the midpoint of KT because they haven't said that that one's also bisected, so we can't mark KM congruent to MT. So when we look at this statement, KM equals MT, that is false. It could be, but we don't know for certain, so we can't say that. KT is a bisector of LH. That we do know, because M is the midpoint and KT goes through HL at the midpoint. That makes it a bisector. Segment MT bisects LH. That is also true. Because it intersects HL at the midpoint, that makes it a bisector by definition. HL is a bisector of KT. We do not know that. They did not tell us that, so that is false. And M is the midpoint of KT. Also false, because we don't know that KT is being bisected. Now we're going to use what we know about midpoints to answer these questions here. So the first one says that B is the midpoint of AC. So since we know that B is the midpoint of AC, we know that AB is congruent to BC. So labeling the picture with what they've told us, 2x minus 3 on AB and x for BC, then we can see that we have two congruent segments. If we want to find x, we will just set x. We know that we will build off of AB equal to BC. So we'll set 2x minus 3 equal to x. It's important to draw your picture and to label it so that you can see exactly what you're looking at from what they tell you. Solving for x, we would minus 2x, giving us negative 3 equals to negative x. Dividing by negative 1 gives us that x is equal to 3. It's also important to look at what they've asked you. They want us to find AC. So even though we found x, we are not quite done yet. We need to take 3 and plug it back in. Remember that AC is going to be equal to the length of AB plus the length of BC. So finding AB, we would do 2 times 3 minus 3, which is 6. And finding BC, it's just 6. So we know, I did that wrong, sorry. 2 times 3 is 6, minus 3 is 3, and BC is 3. So AC has to be equal to 3 plus 3, which is 6. Moving on to number 7, E is the midpoint of DF. So since we know that E is the midpoint, then we know that DE is congruent to EF. Since DF is x plus 6, that's the entire length, and then DE is x minus 2. We are looking for EF. You can look at this in one of two ways. You can look at it as DF is equal to DE plus EF, or you can think of it as DF is equal to 2 times the length of DE. DE does not equal DF. DE is equal to half of DF, which could be another way of thinking about it. DE equals 1/2 DF, but we don't want to work with fractions, so we try to avoid that. So when you set it up and work it both ways, DF being x plus 6, DE is x minus 2, well, we need to know what EF is. Well, since EF is the same as DE, then we can just put x minus 2 twice, because EF could also be thought of as x minus 2. And the other way, you would have x plus 6 equal to 2 times x minus 2. While both of the equations start differently, you can see in the next step that they both become the same. So when I combine my like terms on the right side here, I get 2x minus 4. When I distribute on the right side here, I get that x plus 6 is equal to 2x minus 4. Both of those equations are the same. So then you're going to minus the x to get x minus 4 is equal to 6. Add the 4 to get 10 is equal to x. Same thing works over here. Once we find that x is 10, we're not quite done yet. They actually still want us to know what EF is. So then we're going to plug back in, because DE is equal to EF. We're just going to plug in. So DE is equal to 10 minus 2. So DE is equal to 8. Since DE equals EF, EF is also equal to 8. One way to check this would be then to plug in 10 for DF. So 10 plus 6 is 16. 8 plus 8 is 16. So we know that we've done it correctly. Taking a look at number 8, we have that XB bisects TW. So that means that BW is congruent to TB. WB, they've told us, is 2x plus 5. And TW, they've told us, is 6x plus 5. Go ahead and try and work this one out on your own, and then check back. You should have worked it out and found that x is equal to 5 halves. I chose to use twice BW equals to TB. But you could have very easily done 2x plus 5 plus 2x plus 5 equals to 6x plus 5. So we get 5 halves for x. Remember that you then need to plug back in to find TB. So TB is equal to BW. So BW is equal to 2 times 5 over 2 plus 5, which will be equal to 10, because 2 times 5 halves is 5, plus 5 is 10. So TB has to be equal to 10. Now take a look at number 9. DG bisects CT at point 0. So the line DG bisects the segment CT at point O, not 0, O. That means that CO is congruent to OT. Remember, it's important to note that you can never take a picture in geometry for what it is. You have to be told things. You can't just assume. So while it looks like CO and OT are not congruent in this picture, they are in fact congruent because they told us they're congruent. So CO is 3x plus 1, OT is 2x plus 7, and they want you to find CT. So take a second, work that out, and then check back. Since you have two parts of a congruent segment, or two congruent parts of a segment, you can set those two things equal to each other. So 3x plus 1 equals 2x plus 7. And then solving for x, you should get that x is equal to 6. Since we are looking for the length of CT, we need to find each length of CO and OT. So you plug in 6 for X for both segments and simplify it out. And then you know that CT is CO plus OT, so you add them together to get 38. You could very easily find just 1/2 and multiply it by 2, but the problem there is you won't necessarily know if you've done something wrong. If you know that CO has to be equal to OT, then if you plug into both and they're not the same, then you know you've done something wrong, so you can try and fix the error before it's too late, like getting it wrong on the quiz. So that's why it's very easy, very good to just plug into both and make sure that it's the same, and then add at the end. All right, so kind of shifting gears here a little bit. You should remember the Pythagorean theorem from lots of times before this. So a squared plus b squared is equal to c squared. Labeling your picture, remember the hypotenuse is always c. And then the legs are a and b. And it doesn't matter which one is a and b, the only one that matters is c, and it is always across from the right angle. So in this example here, we're going to draw a triangle and then find our missing side. So our right triangle angle is here, so c is here, a is here, and b is here. So a is 5, b is 12, and c is what we don't know. So we're just going to plug in and do 5 squared plus 12 squared, and that will give us c squared. 5 squared is 25, plus 12 squared is 144, gives us c squared. 25 plus 144 is 169. To get rid of a square, we just square root both sides, so that we get 13 is equal to c. You try number 11. Looking at number 11, you should have done a squared plus 15 squared equals to 17 squared. So then you would subtract 15 squared from both sides and then square root to get 8. Remember, the bigger number will always be on, or the biggest number will always be on the right because C will be the longest side of your triangle. Looking down to number 12 with the distance formula, you can do this in 2 ways. You can use the distance formula that is here on the screen for you. The caveat to that is you have to remember that big long formula, or you can graph them and use the Pythagorean theorem. So let's graph those 2 points on this graph. I can see that I'm not going to be able to graph them because there's only up to 6 on my graph. So I'm going to count by 2s. And put the 7 down here in the middle. And then the Q will be up over here. To use the Pythagorean theorem, you just need to complete your right triangle and then count the length of each side. So remember, you counted by 2. So 2, 4, 6, 8 on the top, and then 2, 4, 6, 8, 10, and then one more makes 11. So using the Pythagorean theorem, you would have 8 squared plus 11 squared will equal to the x squared. 8 squared is 64 plus 121 is equal to x squared. So then that would be 185 is equal to c squared. So, is equal to x squared. So x will be the square root of 185, which is approximately 13.6. You can do this using the distance formula. So you would just label this as x1, y1, x2, y2, and then you plug them in where you see them in the equations. So x2 would be -6 minus 2 squared plus 4 minus -7 squared. -6 minus -2 is -8 squared, plus 4 minus -7 is 11 squared. So you can see the -8 and the 11 come from the lengths of my triangles because that's the distance that they went. Squaring a number always gives a positive, so we get 64 plus 121 which was right over here. And then we're left with the square root of 185, which was right here. So that equals 13.6. So either way, you get the same answer. The Pythagorean theorem is technically what you're doing when you're doing the distance formula. The distance formula is just used, they created it using unknown values with the Pythagorean theorem. Even if you don't have a graph, all you're doing is finding the distance between each coordinate, just like we did the other day in class with just a plain number line. You can choose to use whichever method you prefer. However, I recommend the Pythagorean theorem because it's less to remember. The distance formula is only helpful if you know the formula. Looking at midpoint, we're going to use this formula, x2 plus x1 divided by 2 and y2 plus y1 divided by 2. Think about it as finding the average of your x's and the average of your y's. So if we want to find the midpoint of PQ, then we're going to do 2 plus negative 6 divided by 2 and negative 7 plus 4 divided by 2. So we're using those coordinates just the way we did in the distance formula, just dividing each of them by 2 and adding them together. 2 plus negative 6 is negative 4, and then divided by 2. And then negative 7 plus 4 is negative 3, and then we'll divide that by 2. So negative 4 divided by 2 is negative 2, and negative 3 over 2 just stays as negative 3 over 2. If you are using a graphing calculator, make sure you hit enter after you do the top and then hit before you divide by 2. If you plug it all in at once, you will likely get the wrong answer. You could also do that by graphing, by finding the halfway mark of going up and over the same amount to get to Q. It's a little bit trickier, but the best way is to, if you look on my green line here, I went over 8. So halfway between would be 4, and then just drop it down until you find the point on the graph. Then you see you're at the negative 2, and then it's hard to get your that middle piece there. So that's why we use the formula. Finding the coordinates of the missing endpoint of AB given the coordinates of the endpoints and the midpoint. So I have this endpoint here of A at 3, 6. So here's A. And then M is at 0, 2. So here's M. They have not given me 2 endpoints here. They gave me a midpoint. So if you wanted to do this graphically or visually, then you could say, okay, I go down 1, 2, 3, 4, and over 3 to get from A to M. So to get to B, I have to do the same thing. I have to go down 4 and over 3 to get to B. So I can see my coordinates of B are at negative 3, negative 2. You can also do this algebraically. So using your midpoint formula, we're going to think, okay, if I knew what B was, then I could get to M. So I would start at A and I would go 3 plus whatever B's X is, and I would divide it by 2. And then I would do 6 plus whatever B's Y is, and then divide it by 2. And that would give me out 0, 2. So that means I want 3 plus X over 2 to equal 0, and 6 plus Y over 2 to equal 2. Solving those two equations, I would multiply by 2. So I get 3 plus X is equal to 0. So X has to be equal to negative 3. And then I get that 6 plus Y is equal to 4. So Y has to be equal to negative 2, which is what we found over here. So my point would be negative 3, negative 2. You can use either method to find the answer to these types of questions. Just know that you can't do this visually if you don't have graph paper. I will answer any questions you have in class. If you could go ahead and mark what questions you have, so I know, that would be great. I'll see you tomorrow.